Hello, everyone out there in the live stream. Thanks for watching live. Hopefully you can participate and give us some questions and feedback and whatnot. And yeah, we're ready to get started. Min, you ready?
Yep.
All right. Min, welcome to Talk Python to Me.
Thanks.
Yeah, it's really good to have you here. I'm excited to talk about building applications with ZeroMQ. It's definitely one of those topics that I think it lives in this realm of asynchronous programming in ways that I think a lot of people don't initially think of. Like, you think of async programming, like, okay, well, I'm going to do threads, and if threads don't work, maybe I'll do multiprocessing, and then those are my options, right? But queues and other types of intermediaries are really interesting for creating powerful design patterns that let you scale your apps and do all sorts of interesting things, right?
Yeah. ZeroMQ has definitely given me a new way of thinking about how the different components of a distributed application can talk to each other.
Yeah, absolutely. So we're going to dive all into that, which is going to be super fun. But before we do, maybe just tell us a bit about yourself. How did you get started in programming in Python?
Yeah, so I got started mostly during college, where I was studying physics and what essentially amounted to a computational physics degree. And that's where I had a professor, Brian Granger, who's one of the heads of the now Jupyter project. I started working with him as an undergrad back in 2006, working on what would ultimately become the first ipython parallel, so interactive parallel computing toolkit in ipython that would eventually...
Oh, that's really cool. What university was that at?
That was at Santa Clara University.
Okay, nice. Yeah, it's really cool. I mean, you were working on physics, but you were also like at the heart of Jupyter, and I guess ipython at the time, right? ipython notebooks is what they were called. Yeah.
Yeah, coming up on 15 years that I've been working on ipython and Jupyter.
Yeah. Nice. And so you basically, did you do programming before you got into your physics, or did you just learn that to get going with your degree?
Just for so I did it for fun in college, but I played around with calculators and stuff in high school, but nothing nothing more complicated than printing out a Fibonacci sequence.
Nice. So were you a TI person? Were you an HP person? What kind of world were you?
Yeah, TI all the way.
Yeah, me too. Obviously, that reverse Polish notation, that was just wrong.
Yeah, although in college we did implement reverse Polish calculators because it's easier.
Yeah,
It's easy to write a parser for that.
Yeah, it's easier on the creator and not on the user, which
exactly.
I feel like computers used to be way more that way, right? Like, oh, it's easier for us to make this way. Well, if you put a little more work, it'll be easier for the millions of people that use it. Well, maybe not millions in the early days, but yeah, very, very interesting. So what kind of stuff were you doing with ipython in the early days? What kind of stuff were you studying with your physics?
So in grad school, I was studying computational plasma physics simulation. So it was particle simulations of plasmas, which are what's going on in stars. I wasn't studying stars, but that's one of the main plasmas that people know about. And so I was doing particle simulations of just studying a system, seeing what happens. And we were working on an interactive scale simulation code that was written in C++. It was a fairly nice and welcoming C++ physics simulation as far as academic C++ physics simulations go.
Yeah.
But essentially, my first year of grad school, I wrote a paper where I had to do a simulation run for 5 days, look at the results, and then change some input parameters and run it again for 5 days, and do that for a few dozen iterations, and then wrote a paper about that. And then ultimately, my PhD thesis was about wrapping the same code in Python so that I could have programmatic, like self-steering, actually by this time driven in a notebook, doing what had been manual, like change it, run it again, doing that automatically by wrapping the C++ code in a Python API. I could do it much more efficiently and actually take something that took multiple iterations of 5 days. I could actually get the same result in a little over half a day, I think.
Wow, that's really cool. So you would run basically a little small simulation with C, and then you would get the inputs to Python and go, okay, well, now how do we adjust it? How do we change that?
And it was actually it was the same simulation, but I had to had to tune the inputs a little bit differently in order to. There were some details of the physics that basically I had to turn some knobs way up because I wasn't constantly watching it. And then it would say like, oh, that number was too big. Turn it down, do it again, and then look and see if it was too big again. Whereas once I had a knob that could be turned while the simulation was running, which is the feature that was missing, I could say ramp up the current in this case. So I was studying the limit of current that you can get through a diode.
Right.
And so ramp up the current, and then once I see evidence that it's too high, ramp it back down, and then I could change, lower the slope so that I would slowly approach an equilibrium and find the limit. Whereas when I had to do it with this long, I had to basically wait until it's done to change the input. I had to dramatically over-inject the current, which made the simulations extra slow because there were way too many particles. And the spatial resolution had to be really fine in order to resolve something called a virtual cathode. And I didn't have to do nearly as much. Basically, because I could do this live feedback, the simulations themselves could be quicker because I didn't have to provide enough information that I could get the right answer out a long time later.
That's super cool, and obviously it makes a huge difference. I feel like we have a similar background in how we got into programming. Like I was doing a math degree, and my math research led me into doing C++ on Silicon Graphics mainframe computers and stuff like that. And you talk about letting these things run overnight. Like everyone would just kick off these things, and then they would come back in the morning to see what happened. And interesting sort of random sidebars. Like we came in one morning and we all tried to log into our little workstations or whatever, and like the system just wouldn't respond. There was just something wrong with it. And we were like, well, what the heck is going on? Like this is like a $250,000 computer. It should let us log in. What is wrong with it, right? And it was in there running really loud, right? It's like this huge loud machine. And it turned out that one of the grad students, not me, had started a job they were trying to figure out what was going on, and they were logging a lot because they were having problems with their code. And it was in this tight loop that ran all night. And because it was like a somewhat small group, they had no disk limits or permission restrictions for the large part. So it literally used up every byte on the server, and then it just wouldn't do anything at all. And I mean, that's the reason I bring this up is like, that's the challenge of these things where you like start it and let it run for days and then figure out what's happening. You're like, oh, it just used up the entire hard drive of this giant machine. Whoops. It broke it for everyone, right? And so this live aspect or more self-guided is a really great idea. It's a big step ahead, maybe more so than people initially like hear it as, right? It's a big deal.
Yeah, and I think that's part of what got me really excited about the programmatic when you have access to something in Python and you have an environment like ipython or Jupyter or whatever, being able to interact with something, what you might think of as an offline physics simulation that runs for hours or days. If you have a Python API to it, you can steer it while it's going. Like you can turn the knobs on your experiment while it's running, and sometimes there are reasons why that's not actually a good idea, but it's really powerful to not. One of the costs that I had in my experiment was that in order to change the inputs, I had to start over. Right? Physically, I didn't have to. Like if it were a physical machine where I were measuring inputs and outputs, I could just turn the current down and see the results. But the code didn't support that. Whereas the frustrating thing about it was the way the physics was written did support that. The C++ code did support that. We just hadn't written an interface that allowed me as the user to do it. And so the Python wrapping work was surprisingly little. It was expose Python APIs or C++ APIs to Python with Cython. And then I could turn all the knobs that were already there in the code. I just was now allowed to turn them.
It sounds to me, thinking back on the timeline there, that must have been pretty early days in the data science, computational science world of Python, right? Like NumPy was probably just about out around then, or what?
Well,
What's
by
that?
the
What time
time I
was
was
that?
by the time I was doing that work, that would have been around 2012.
Oh, okay. So
Um,
yeah, it was more established at that point. I was thinking back to like early, like 2005 or something. That, yeah, not quite right.
Yeah, not quite. That was when I was still, as a little undergrad, was still able to help make building NumPy. I was able to submit patches to make building NumPy on Mac a little easier.
That's cool. Before it became like completely polished and like
Yeah.
so widely used. I suspect it's really nerve-wracking to contribute to those kinds of things now.
Yeah, it was pretty exciting, but it was, it was a nice community, and it was exciting to be able to say, like, I have a problem. There's probably other people who have a similar problem. Let me see if I can fix it, and then submit a patch.
Yeah, that's
And
fantastic. Cool. So you're carrying on with your scientific computation work these days, right? What are you up to now?
Well, so now my job is actually working on Jupyter and ipython related stuff. So I am a senior research engineer at Simula Research Lab in Oslo, Norway, where I've been since 2015, and I'm the head of the Department of Scientific Computing and Numerical Analysis. So I'm in a department where people are doing physical simulations of the brain, and studying PDEs and things like that. But what I do is I work on Jupyter Hub.
Yeah.
So we made Jupyter Hub as a tool for deploying. While I was still at Berkeley, we made it as a tool for deploying, for people who want to deploy Jupyter notebooks. We say it's for if you're a person who has computers and you have some humans and you want to help those humans use those computers with Jupyter. That's what Jupyter Hub is for.
Mm-hmm.
And so that initially was scoped to be an extremely small project because we didn't have any maintenance burden to spare. The target of that was like research groups like mine in grad school, of like a few people, maybe small classes, who have like one server in their office and they just want to make it easier for people to log in and use Jupyter on there. Right. This was when people people had all their like SSH tunnel, reverse SSH to my server with the open or reverse tunnel so I can point localhost and it's actually over there. So we were trying to make life easier for those folks. But then
they were running the servers locally and they're like, how do I get access to my computation over there, but on my machine, that kind of stuff, right?
Yeah, it's like if I'm a person who's already comfortable with Jupyter, but now I have access to a computer that's over there, how do I run my notebook stuff over there? And there were a few solutions to that with involving SSH tunnels or whatever. And Jupyter Hub was aimed at those folks. But it turned out that's not the user community that's really been the most excited about it. With things like Zero to Jupyter Hub, the Jupyter Hub on Kubernetes, started by UV Panda, now led by a whole bunch of wonderful folks. We were shifted into a larger scale than initially designed for.
Yeah, it definitely seems like Jupyter Lab and the predecessors to it have really probably exploded beyond the scale that people initially expected. I mean, it's just the de facto way of doing things if you're doing computation these days, it seems.
For certain folks definitely seem to like it. And we try to respond to feedback and just build things that people are going to use.
Nice. So if you're running Jupyter Lab for such a big group, I mean, there's got to be crazy amounts of computation and supercomputer type stuff there. Like, what does your whole setup look like there? Like, what are you running for your folks at the research lab?
So I run Jupyter Hub instances for like a summer school. They'll run a workshop, and I'll spin up a cluster for running Jupyter Hub for doing some physics simulations. Usually, it's for teaching. So I don't operate hubs for research usually. I usually operate them for teaching, and then the computational.
So maybe the computation there, it's like not nearly as high as we're trying to model the universe and.
Yeah, that's right. Usually, often those folks, the computation are handed off somewhere. But yeah, like the folks at NERSC in Berkeley are doing some really exciting stuff with running Jupyter Hub on a supercomputer.
Yeah, cool. Are you doing like Kubernetes or Docker, or are you just setting up VMs, or how do you
currently
handle that side?
Thanks to the work of the all the folks contributing to Zero to Jupyter Hub, deploying Jupyter Hub with Kubernetes, I think, is the easiest to deploy and maintain as long as you have access to a managed Kubernetes. I still wouldn't recommend deploying Kubernetes itself to anybody.
It seems fairly complicated to run and maintain that side of things. Yeah.
But if you have a turnkey solution, the one I use the most is GKE, the Google managed Kubernetes. And Zero to Jupyter Hub let you just step through and say, give me a cluster and run Jupyter Hub on it. And then all I really need to do is, for the workshop, is build the user images.
Nice. Very cool. You also do some stuff with Binder, is that right?
Yeah, so I help operate Binder. So mybinder.org is a service built on top of Jupyter Hub that takes Jupyter Hub as a service for running notebooks on Kubernetes. In Binder's case, it's running on Kubernetes. And Binder ties in another Jupyter project called repo to Docker that says, look at a repo, build a Docker image with the contents of that, hopefully that can run everything. So like if it's
preferably it's got a requirement. Yeah, exactly. It's got something that specifies its dependencies or something.
Yeah, and there's a bunch of things that that we support. And the idea is to automate existing best practices, right? So find anything that people are already using to specify environments, and then install those, and then build an image. And then what Binder does is, so I built an image, then send that over to Jupyter Hub to say launch a notebook server with that image.
Right. So yeah, you can see like right here, just on the main site, you just put it in a GitHub repo and maybe a branch or a tag or something, and then click go, and then it spins up literally a Jupyter notebook that you can play with. You know, when people go to GitHub, they can oftentimes see the Jupyter notebook. And always, when I first saw that, I'm like, how in the world is GitHub computing this stuff for me to see, right? Like I see, I'm like, maybe that is like super computationally expensive. And here's the answer. And like, how do they know the data and the dependencies? And the reality is they've just taken what's stored in the notebook, right? That is the last run, and it's there. But if you want to play with it, you can't do that on GitHub, but you can on mybinder.org, right? That creates turns that into an interactive notebook.
Yeah, it adds interactivity to the sharing that you already have with NBViewer or GitHub.
Yeah, nice. Yeah, very cool project. I didn't know that much about it, but I had Tim Head on the show a while ago on episode 256 to talk about that, and I learned a lot. So yeah, quite neat. Now, let's jump into ZeroMQ.
Yeah.
So, ZeroMQ is not a Python thing, but it is very good for Python people, right? It has support for many different languages, and your work primarily has been to work on making this nice and easy from Python, right?
Yeah, so ZeroMQ is a C++, a library written in C++ with a C API, which makes using it a little easier. And it's a very small API, which is part of why it's usable from so many languages, that writing bindings for it is relatively easy. And the idea of ZeroMQ is it's a messaging library. Its name is a little funky because it comes from the world of, the people who create it come from the world of message brokers and message queues, and ZeroMQ is a bit tongue-in-cheek, and it's not actually a message queue at all. It's a messaging library where it's just adding a little bit of a layer of abstraction on the networking, in terms of you have some distributed application where things need to talk to each other, and ZeroMQ is a tool for building that. And it's this library, and then you can write the bindings for that library so that you can use it from any of a variety of languages. And so Brian Granger and I worked on the Python bindings to use ZeroMQ from Python, which is called PyZMQ.
Yeah, when I first thought of it, I imagined it as like a server, something like Redis or Celery or something like that you start up, and then you create queues or something on it, and then like different things can talk to it. But I think maybe a better conceptualization of it might be like Flask, right? Flask is not a server, but a Flask is a framework that you can put into your Python app and then run it, and it is the server itself, right?
Yeah, and so I'd say that ZeroMQ, the best way to describe it is it's a fancy socket library.
Yeah.
So you create sockets and you send messages. And the sockets talk to other sockets. You send messages, you receive messages. And then ZeroMQ is all about what abstractions and guarantees and things it gives around those sockets and messages.
Yeah. There seems to be a lot of culture and zen about ZeroMQ. Like there's a lot of interesting like nomenclature in the way that they talk about stuff over there. So they talk about the zero in ZeroMQ, and the philosophy starts with zero. Zero is for the zero broker. It's brokerless. Zero latency, zero cost. It's free. Zero admin. You don't have like a server type of thing. But also to a culture of minimalism that permeates the project, adding power by removing complexity rather than exposing new functionality. You want to speak to that just a little bit, like your experience with that?
Well, so I can speak to that as someone who doesn't work on libzmq that much, more somebody who writes bindings for it. I can speak
Right.
to that as it's nice that libzmq doesn't change that much,
Yeah.
and that part of the point of ZeroMQ has all these features. They have we can talk about a little bit about it in a second, but so it's structured so there are sockets, and there are different kinds of sockets that have different behaviors for building these different kinds of distributed applications. But in terms of the API, there's just one. Like a socket has an API. All sockets have the same API. So from the standpoint of writing bindings to a library, I just need to say, I know how to wrap the socket APIs. And then as they add new types, those are just constants that I need to handle. So I don't need to, oh, there's a new kind of socket. I need to implement a new Python class for that new kind of socket. I just need to wrap socket.
Yeah.
And so that's from my perspective in terms of as new features are developed and things in libzmq, from my perspective as a binding developer, binding maintainer, that's really nice. But that also extends to the application layer, that once you have a socket and you understand sockets, changing the type of socket changes your message pattern. It doesn't change anything about the APIs you need to use and things like that.
Yeah. So maybe we could talk a little bit about what the application model. I don't necessarily want to get into programming yet, but like the application model, right? So we've got contexts, we've got sockets, and we've got messages. And those are the basic building blocks of what working with this is like. So if I wanted to create something that could, maybe other applications could talk to it and exchange data, one of my options might be to create a RESTful API that exchanges JSON, right?
Yeah, sure.
There's a lot of challenges with that. One, it's sort of send request only, right? I send over my JSON and then it gives me a response, but I can't subscribe to future changes, right? I got to do something like WebSockets in that world if I want something like that, which I guess might be closer to this. And then also it's doing the text conversion. It's probably a little bit slower. You got to do maybe extra work for async, right? So there's a lot of things that are maybe similar, but extra patterns, right? So instead of just request response, you might have pub sub, you might have like multicast, like something comes in and everyone gets notified about it. Could you talk about some of those differences, like maybe compare it to what other like more common APIs people might know about?
Yeah, so the main thing that distinguishes ZeroMQ is that a context is kind of an implementation detail that you shouldn't need to care about, but you still need to create. Sockets are the main thing that you deal with, and you create a socket, and every socket has a type, and that type determines the messaging pattern. So that means that's where we're getting at these kind of protocols and messaging patterns. So with a web server, that's usually a request reply pattern. So you have clients connect, send a request, and then they get a reply. A pub sub system might be some totally different thing. Maybe in web server land, maybe it's server side events, an event stream connection. And with ZeroMQ, the difference between those is the socket type. So if you're creating a publish subscribe relationship, you create a publish socket on one side and you create a subscribe socket on the other side. If you're doing a request reply, you use a socket called a dealer and a router. There's a request and a reply socket in ZeroMQ, but nobody should ever use them. They're just a special case of router dealer. And then there's another one called a pattern called like a ventilator and sync. So that's like what you'd use in a work queue, for instance, where you've got a source of work, and then it sends a message to one destination, but you don't necessarily care which one.
I see. So maybe you're trying to do scaled out computing.
Yeah, exactly.
And you've got 10 machines that could all do the work, and you want to somehow evenly distribute that work, right? So you're like, all right, well, we're just going to throw it at ZeroMQ. All the things that are available to do work can subscribe. If they need to, they could even like drop out after doing some work, but then not receive anymore potentially.
Yeah, exactly. And that's what ZeroMQ, one of the main things that ZeroMQ does is it takes control over those things like multiple peers and connection events and stuff like that. Because take for example, the publish subscribe. There's two key the things to think about with ZeroMQ are what happens when you've got more than one peer connected,
right?
And what happens when you've got nobody to send to. So in the publish subscribe model, what it does is when you send a message on a socket, it will immediately send that message to everybody who's connected and ready. So if somebody's not able to keep up, right, there's like a queue that's building up and it's gotten full, it'll just drop messages to that peer until they catch up. If there are no peers, then it's really fast because it just doesn't send anything and just deletes the message. Right, so when you're thinking of ZeroMQ from Python, sending messages is really the other thing about it is that it's asynchronous. That send doesn't return when the message is on the TCP buffer or whatever. Send returns when you have handed control of the message to the ZeroMQ IO thread. And this is why ZeroMQ has this concept of context. Contexts are what own the IO threads that actually do all the real work of talking over the network. So when you're sending in PyZeroMQ, you're really just passing ownership of the memory to ZeroMQ, and it returns immediately. And so you don't actually know when that message is finally sent, and you shouldn't care. Sometimes you do care, and it can get complicated. But ZeroMQ tries to make you not care.
Interesting. So basically, you set up the relationships between the clients and the server through like these different models, and then you drop off the messages to ZeroMQ, and it just it deals from there, right? It figures out who gets what and when, and so your application, as soon as it gets the message passed off to the ZeroMQ layer, it can go about doing other stuff, right?
Right, exactly. So ZeroMQ, because it's a C++ library, it's not going to grab the GIL or anything. So it's a true, even if you're using Python, it's a true multi-threaded application, even if you're only using one Python thread.
Yeah.
Because you hand that memory off to C++, which is running in the background. You can do some GIL holding intense operation, and ZeroMQ will be happily dealing with all the network stuff.
Right. It's got its own C++ thread, which has nothing to do with the GIL, and they go do its own thing, right? Nice.
It can. There is something that comes up in PyZeroMQ where it can come back and try to grab the GIL from the IO thread, or it used to. It doesn't anymore because of Python does actually need to know when it let go of that memory in order to avoid site faults. But that's an implementation detail.
Right. Okay. Cool. So is there anything about reliable messaging here where you could say I want to make sure that this message gets delivered to every client? Like if you said, for example, in this pub sub, if some of them fall behind, it can just drop the messages. Is there a way to say, pile that up and then send it along when it catches up or whatever?
Yeah. So the ZeroMQ perspective is that that's an application level problem. So ZeroMQ helps you build the messaging layer to not so that it doesn't crash, and that's part of why it drops messages. And then it's up to you to say, if you're sending messages and there's a generation counter, for instance, and you notice I got message 5 and then I got message 8, it's up to your application to say, okay, keep a recent history buffer so that folks can come back with a different pattern, a request reply pattern, to say, give me a batch of recent messages that I missed so that I can resume. But ZeroMQ doesn't help you with that.
Yeah. Okay. but it handles all the networking stuff. So, the connections, you don't have to worry about that. You just have to worry about like, how do we set up a way to ask again, or have the application ask if it wants more. Yeah.
Mm-hmm.
Nice. David out there on the live stream asked what alternatives to ZeroMQ could have been used to build the Jupyter protocol. So maybe before we, great, thanks for the question. Before we get to that though, maybe let's just talk about like, oh wait, ZeroMQ was used to build the Jupyter protocol?
Yeah. So the Jupyter protocol, which essentially started out in ipython parallel. So we had this interactive parallel computing networking framework that evolved into, wait, we've got this network protocol for remote computation. We can build basically a REPL protocol, an interactive shell protocol, and that ultimately became the Jupyter protocol, which was built with this kind of ZeroMQ mindset of, I want to be able to have multiple front ends at the same time. So let's say, and we had in 2010, I think, Fernando and Brian had a working prototype of real-time collaboration on a terminal. So you've got using this protocol, so you've got two people with the terminal, you're typing, you can run code and you can see each other's output. So we built the Jupyter protocol with multiple connections in mind. So that means there's this request reply socket. So the front end sends a request, please run this code. And the back end sends a reply saying, I ran that, here's the result. And there's another channel called IOPub where we publish output. So when you do a print statement or you display a matplotlib figure, that's a message that goes on a pub sub channel, which means that every connected front end, right? So you could have multiple Jupyter Lab instances. They'll all receive the same message.
Right. I mean, that sounds like the perfect example of pub sub. Right? Somebody's making a change. Well, somebody has triggered the server to make a change, but it doesn't matter who started that change. Everybody looking at it wants to see the output, right?
Right. And so to answer the question of, and this becomes particularly important in the design of ipython parallel, but getting to the question of what alternatives to ZeroMQ could have been used for the Jupyter protocol. So when we were designing it, we thought this protocol of talking directly to kernels was going to be the main thing. It turns out that the main way, in 2020 or 2021, I guess we're in now, the most kernels talk one-to-one with a notebook web server, and it's the web server that's the one that's actually spanning out to multiple clients. Right. With that being the case, if we had required the notebook server to be the place where we do all the multiplexing and everything, we could have actually built the lower level Jupyter protocol on something much simpler, just an HTTP REST and event stream. Probably could have worked just fine.
Right. Maybe just use WebSockets or something on the web server side.
Yeah. If WebSockets had existed at the time.
Yeah, sure. Yeah, I mean, that's so much easier. Yeah, that's so much of that stuff's easier now, and the browser support it and so on. So yeah, super interesting. Now, one thing that makes me think of is, how close are we, or to some sort of Google Docs Jupyter Lab type of thing, right? I mean, we're not there, right? I know there's SageMath and there's Google Colab. There's other systems where this does exist, right? Where there's sort of, we can all type on the notebook, same cell, same time type of thing. Is there anything like that Jupyter Lab that I just didn't miss, or I missed, or? So
there've been I think 3 prototypes at this point that have been developed and are and ultimately not finished for various reasons. There's another one that's picking up again and going strong using YJS. Working with QuantStack, I believe. Okay. So hopefully soon. That's not an area of the project where I've done a lot of work. I helped a little bit with the last one.
Well, I mean, to me, it sounds like that's like just all JavaScript front end craziness, and not mostly a whole lot of other stuff, right? Like,
yeah, the state probably lives on the server, so you need to have a server, whether it's running CRDT or whatever, to synchronize the state.
And the pub sub, as well for the changes. Going down the rabbit hole for a minute, I'll also Nawa asked an interesting question about ZeroMQ. You know, what's the story with ZeroMQ and microservices, right? Like, when I think microservices, people often set up a whole bunch of little small Flask or fast API things that talk JSON exchange, request response, but man, like the performance and the multiplexing, all those types of things sound like it actually could be a really awesome non-HTTP based microservice.
Yeah, I think ZeroMQ is a really good fit for microservice based distributed applications, because one of the things you do when you're designing with microservices is you're defining the communication relationship and you're scaling axes. And a nice thing to do with ZeroMQ is to say is that your application doesn't change when you've got a bunch of peers. Your application doesn't even need to know when a new peer comes and goes, because ZeroMQ handles that. So one of the things that's nifty about, that's weird and magical but also really useful about ZeroMQ is it abstracts binding and connecting and transports. So you can have the same application with the same connection pattern, and maybe this one binds, and maybe one side binds and one side connects. So pub binds and sub connects, but you can also have sub bind and pub connect. You can also have your pub bind once and connect 3 times, and none of that changes how your application behaves. It just changes where the connections go.
Right.
So
with microservices, when you're doing HTTP requests, you always got to figure out, okay, well, what's the URL I'm going to? And sometimes that even gets real tricky with what is even the URL of the identity server? What is the URL of the thing that manages the catalog before I even request it? And then usually that's a single endpoint HTTP request type of thing, if it's like an update notification. So yeah, I can imagine that there's some real interesting things here. The other thing is, sorry, go ahead. No, go ahead.
Yeah, so you can have in a distributed work kind of situation, you can have one or a few sources of work, and then you have an elastic number of workers that just connect and start receiving messages. And the way this is in kind of the push-pull pattern. So pub sub is always every message you send it to everybody connected who can receive a message. Whereas push-pull is whenever you send a message, send it to exactly one peer, and I don't care which one. Yeah. And so if more peers are connected, it will load balance across all those peers, but if only one's connected, it will just keep sending to that one. And at no point in the sender do you ever need to know how many. You never get notified that peers are connecting. You never need to know that there are any peers, that there's one peer, that there's 1,000 peers. It doesn't matter. So then it's in your distributed application to say, this one's sending with this push-pull pattern, ventilator sync pattern, and then I just elastically grow my number of workers and shut them down, and they just connect and close, disconnect, and everything, and it just works.
Interesting. Okay, so a follow-up question from Nawa that makes me think. So she asked whether it is a good idea to replace REST communication with ZeroMQ, and so that leads me to wonder. You talked about you send the message and it's sort of fire and forget style, like message sent, success. But so often what I want to do is I need to know what products are offered on sale right now from the sale microservice or whatever. I need to get the answer back. These 3 products. Thank you. You know what I mean? How would I implement something like that where I send a message, but I want the answer?
Yeah, so that's the request reply pattern. So you would use either the request reply sockets or the router dealer sockets for that kind of pattern. And that's, you send a message. So in that case, this does have multi-peer semantics, but usually the requester is connected to one endpoint. It can be connected to several, in which case it'll load balance its requests. And the router, so the receiver side, handles requests, and each request comes in with the message prefix that identifies who that message came from, and then it can send replies using that identity prefix, and it will go to whoever sent that request. And that's how most of the Jupyter protocol is, a request reply pattern.
Yeah, sure. I guess that makes sense because you want the answer from the computation or whatever. Once you know that it's done and so on. Interesting. Okay, yeah. Well, that's pretty neat. What the other thing that comes to mind around this is serialization. So when I'm doing microservices, I make JSON documents. I know what things go in JSON, right? Like fundamental types, strings, integers, and so on. Surprisingly, dates and times can't go into JSON. That blow. I still like, this is 2021. We can't come up with a text representation of what time it is. Anyway, so that's a bit of a pain. It seems to me like you might be able to exchange more data more efficiently using a binary, and it's not even going over the HTTP layer, right? It's going literally over a TCP socket.
Yeah, or IPC with BST sockets or UDP.
Like even lower level than that. Yeah, not even touching the network stack, right?
So yeah, this gets us to the last piece of ZeroMQ that we haven't talked about yet, and that's what is a message. So one of the other nice things, if you've worked with a lower level socket library, just talking TCP sockets, you have to deal with like chunks and then figure out when you're done with your message protocol. But if you've ever written an HTTP server, you need to find those double blank lines and all that stuff before you know that you have a request that you can hand off to your request handler.
Right. You're doing a whole lot of funky, like parsing the header. Okay, in the header it says it's the next 100 bytes of the thing that I'm getting, and this one is an int, so I'm at a part. Like it's gnarly stuff. I've worked on projects where we did that, and it's super fast, but boy, it's low level business.
Yeah, and that's what something like Flask does for you, right? It implements the HTTP protocol and then says, okay, here's a request. Please send a reply, and it helps you construct that reply message. So ZeroMQ or PyZeroMQ live at that level of Flask, where a message is a not one binary blob, but a collection of binary blobs. And ZeroMQ always delivers whole messages, so it's atomic and it's asynchronous in its messaging, which means you will never get part of a message. There's no like, okay, I got the first third of this message, keep it in my own buffer until I get to the end. A ZeroMQ socket does not become readable until an entire message is ready to be read.
Right, and there may be buffering down at the C++ layer, but it's not going to tell you I've received a thing until it's fully baked.
Right, yeah, all that stuff still happens. It's just ZeroMQ takes care of that, and then when at the PyZeroMQ level or at the ZeroMQ API level, when you receive with a socket, or in PyZeroMQ you say receive multipart, you get a list of blobs of memory. And so if you're talking about serialization with JSON, so PyZeroMQ has a helper function called sendJSON, and it's literally just JSON.dumps thing and then send it. With a little ensuring UTF-8 bytes, I think.
Yeah, nice.
So PyZeroMQ, it's and this is really turned out to be really more important for IPython parallel than it turned out to be for the Jupyter protocol.
I'm not familiar with IPython parallel. Tell me about this.
So IPython parallel is so if you're aware of the Jupyter protocol, it's a network protocol for I've got somewhere over the network where I want to run code. And I have this protocol for sending messages, please run this code, give me return output, show me display stuff. IPython parallel is a kind of weird parallel computing library based on the fact that, so I've got a network protocol to talk to run code remotely. Why don't I just wrap that in a little bit to talk to n remote places.
Maybe partition up the work across them or something like that.
Yeah, exactly. And the fun thing about ZeroMQ is that in a Jupyter notebook, the kernel is the server. The kernel listens for connections on its various sockets. And then the notebook server, the web server, or the Qt console, or the terminal is a client, and it connects to those sockets. IPython parallel, because of this fun stuff about ZeroMQ not caring about connection, direction, or count, adds a scheduler layer, and it modifies the kernel, the IPython kernel that you'd use in a Jupyter notebook, and the only change it makes is instead of binding on those sockets, it connects to a central scheduler. And the kernel is otherwise identical, the message protocol is otherwise identical, but the connection direction is different because the many-to-one relationship is different. There's one controller and many engines instead of many clients connecting to one kernel. And then again, using kind of some of the magic of the ZeroMQ routing identities, there's a multiplexer in PyZeroMQ called a monitored queue, where if you have router socket, so a router socket is one where the first, so we talked about a ZeroMQ message is a sequence of blobs of memory. So it can just be one. With a router socket, it's always at least two, because the first part is the routing identity to tell the underlying ZeroMQ which peer should it actually send to.
Sure. Okay. That's cool. And we don't have to worry about that because that's down at the low level, right? But that's what happens.
Well, you need to know about it in that you need to, when you get a request, you need to remember that first part. So when you send the reply, the first part of the reply is the ID that came with the request.
Got it. So it goes back to the right place.
Yeah.
Okay.
But you can also use that if you know the IDs, you can send messages to a destination without being in response to a request. Right. What a router really is a socket that can route messages based on this identity prefix. So if you have a bundle of identity prefixes, then you can send messages to anyone at any time. And that allows us to build a multiplexing scheduler that from one client connected to one scheduler, just send messages, regular, plain old ZeroMQ protocol messages, but with an identity prefix from the client. And those will end up at the right kernel just by the magic of ZeroMQ routing identities.
Yeah.
And so this is a substantially different messaging pattern. So the request-reply patterns are all the same, but the connection patterns are totally different. And the client and the endpoint don't need to know about it at all. We just have this adapter in the middle.
I feel like to really get the zen of this and take full advantage, you've got to really think about these messaging patterns and styles a little bit, because they're fairly different than, this is what I know from web servers.
Yeah, so the big thing to do with if you're getting into ZeroMQ is to read there's something called the guide. So there'll be a link in the notes, and if you go to zeromq.org, it'll be prominently linked. This goes through kind of the different patterns that ZeroMQ thinks about, the abstractions in ZeroMQ, and the different socket types and what they're for. And the guide will help you, and there are examples in many languages, including Python. And
this seems great.
Build kind of little toy example patterns of, here's a publish subscribe application, here's a ventilator sync application, and then it also does things
pictures.
with So it's that's I think the way to internalize what are the ZeroMQ concepts and how do I deal with this. So when it comes to serialization, this is really important for ipython parallel. And it also comes up if you're in Jupyter and you use the interactive widgets. If you use the really intense ones that do like 3D visualization, interactive 3D visualization in the browser that sometimes are streaming a lot of data from the kernel. Because a ZeroMQ, this combines two things, one from PyZeroMQ and one from ZeroMQ itself. So the ZeroMQ concept that a message is actually a collection of frames. This lets you and another, that ZeroMQ can be zero copy, and PyZeroMQ supports zero copy. So anything that supports the Python buffer interface can be sent without copying, meaning it's still copied over the network, but at no point are there any copies in memory. So you can send, a 100 megabyte NumPy array with ZeroMQ without copying it. But then you've got to think about, oh wait, if I send a NumPy array using the Python buffer interface, all I got were the bytes. Where's the D-type information? Like, how do I know this is a 2D array of integers? Because a message is, in Python language, is a list of blobs instead of a single blob, you can serialize that metadata as like a header and the blob you don't want to copy, the big one, separately. So you can say like JSON dumps some message metadata that tells you how to interpret the binary blob, and then just the binary blob, and you don't copy it. So then you can send as one message, right? We're not breaking the single message delivery. You have your metadata that's serialized with message pack.
It comes in as like a frame or something like that in the message. Yeah.
Yeah. So one frame is your header. One frame is the data itself. And we do this in the Jupyter protocol, that the Jupyter protocol has an arbitrary number of buffers on the end. But then there are 3 frames that are actually JSON serialized dictionaries.
Nice. Oh, very cool. Very cool. Yeah, looking at the guide here, it says there's 60 diagrams and 750 examples in 28 languages. That's a big cross-product matrix of options in here. And you can also download it as a PDF to take with you, which, yeah, this looks like a really great place to get started. Speaking of getting started, let's talk about programming with the Python aspect here. All right. So here we'll use PyZeroMQ, and this is a library that you work on as well, yeah?
Yeah, I maintain PyZeroMQ.
Yeah, awesome. So maybe, it's hard to talk about code, but just give us a sense of what it's like to create a server. Like in Flask, I say app equals Flask, and then I decorate app.route on a function. Like what's the ZeroMQ Python equivalent of that?
Yeah, so you first you always have to create a context, and then use that context. Context has a socket method that creates sockets, and then you either bind or connect those sockets, and then you start sending and receiving messages. So if you're writing a server, which usually means this is the one that binds.
Yeah.
So you'd create a socket, you'd call socket.bind and give it a URL, maybe a TCP URL or an IPC URL with a path, a local path, and then you'd go into a loop saying, receive a message, handle that message, send a reply, or if it's a publisher.
Yeah, sorry, they often have a while true loop sort of thing, right? Just while true, wait for somebody to talk to me, or while
that's a simple version, or you could be integrated into async IO or Tornado or gevent or whatever.
Yeah. Yeah, that one of the fundamental principles of ZeroMQ is that it's async all over the place. What's the async and await story with PyZeroMQ? So, is there any integration there?
Yeah, so if you do import zmq.asyncio instead of if you do import zmq.asyncio as ZeroMQ, you will have the same thing, but send and receive are awaitable instead.
Oh, that's glorious. Yeah, that's really, really fantastic. So you should be able to scale that to handling lots of concurrent exchanges. Pretty straightforward, right?
Yeah, and that's how so taking Jupyter as an example again, so the Jupyter notebook uses the Tornado framework, which if you're getting into async IO, Tornado is basically async IO before async IO.
Right, yeah, it's early days, early take async IO, yeah.
Yeah, so and there we use something called a ZMQ stream, which is something inspired by Tornado's IO stream, which is their wrapper around a regular socket. That's like bytes are coming in, call events when bytes have arrived. ZMQ stream is a Tornado thing that says when you have an on-receive method that passes a callback that says whenever there's a message, call back with the message after receiving it. Yeah, and so that's actually how the ipython kernel and Jupyter Notebook work on the ZeroMQ side, is with these ZeroMQ stream objects.
Yeah, cool. So the example you talked about is how to create a server, but the web version would be use request to do a request.get against the server to be the client that talks to it. What's that version in PyZeroMQ?
In PyZeroMQ, a client looks very much like a server, except instead of bind, you'd call connect. And
instead of receive, you do a send, yeah?
Yeah, and so in a request reply pattern, so wherever you have a receive on the server side, you have a send on the client side, and vice versa. So in a request reply pattern, the client is doing send a request and then receive to get the reply. In a server, you're doing receive a request and send the reply. In pub sub, you're only sending. On the publisher side and on the subscriber side, you're only receiving.
Nice. And when the way you set this, you basically choose these things is when you go to the context and you create the socket, you tell it what kind of pattern you're looking for. Is that where you specify that?
Yeah, so ZeroMQ has a bunch of constants that identify socket types. So you'd use, when you create a socket, you always have to give it a single argument that is the socket type. So it'd be like ZeroMQ.pub for a publisher socket, ZeroMQ.sub for a subscriber socket, router, dealer, push, pull. And that defines the messaging pattern of the underlying sockets.
Nice. And sorry. You also have some Jupyter Lab examples, which I guess we can link to as well, like some diagrams for that, right?
Yeah. So the Jupyter protocol has a diagram of a diagram that we maybe should redesign.
Okay, I didn't mean to go that far. There we go.
That shows you what happens when you have one kernel and multiple front ends connected to it with the different socket types that we have in the Jupyter protocol. So the Jupyter kernel has 2 router sockets and a pub socket, and a fully featured front end would have 2 dealer sockets or request sockets and a sub socket.
Wow, how neat. It's just so much is happening below the scenes. I think getting your mind around these is really neat, but basically ZeroMQ is handling so much of this for everyone, right?
Yeah, it's handling all the, so we never care about there's multiple peers connected. We don't need to deal with that. We have no connection events. Some folks working on different issues that causes headaches for them because, so there's some aspects of ZeroMQ, like the not guaranteed pub sub delivery is actually kind of a pain because because we actually want all the messages.
Yeah, of course. Is there any, around a lot of libraries, there's stuff that like adds layers that does stuff. So like Flask extensions and stuff like that. Is there an extension that will like let you do reliable messaging that you can plug in on top of this?
So there are, like that? Yeah. So if you look at the ZeroMQ guide, there are different patterns, some of which are basic uses of sockets. So there's no reason to build another layer of software on in order to implement that, like a simple ventilator pattern. But if you're talking about things like reliable messaging, there are some patterns in the guide, and they have names. And so some people have written those protocols as standalone Python packages that say like implement this scheme on top of ZeroMQ that might have things like message replay and or election stuff. Like if you do Kubernetes things, they're often leader elections to allow you to scale and migrate things. So you can do that with ZeroMQ applications too.
Yeah, and some of those reliable messaging things sound amazing. And I go, oh yeah, that's gonna be great. But there's other drawbacks to those as well, like poison messages. Like, I got to make sure I send this, but the client can't receive it, so they crash. So then I try to send it again, and you're just in these like weird loops. And there's a lot of they all have their challenges.
Yeah.
So another thing that I think would be interesting to touch on for our conversation, which we've spent so much time talking about all the programming patterns and stuff that I don't know we have as much time maybe as we imagined, but
yeah, that's fine.
Building ZeroMQ for basically to wrap this C library, right? This is some challenges you've had. It supports both CPython and PyPI. Sorry, PyPI. And whatnot. So maybe talk about some of the ways you did that. You had to do this like in the early days when there was Python 2 and 3. There's a lot of stuff going on, maybe pre-Wheels, right?
Yeah, so a few years pre-Wheels. So with ipython and Jupyter, our target audience is pretty wide, right? We have a lot of people in education, a lot of students, a lot of people on Windows.
A lot of those people don't even want to be programmers or care about like the nuance. They just want this to work. And why won't this thing install? I just need to do this for my class or for my project. It needs to work, right?
And so having a compiled dependency was a big deal for a lot of people. And so making binary releases as widely installable as possible was really important to us. And supporting as many Python implementations as possible was also important to us. So PyZeroMQ was originally written all in Python, which is a wonderful library for this when you're interfacing with the C library, especially when you want to do things with the buffer interface. So when you have a C object and a Python object that represent the same memory, Python is the best.
Right.
And so that's a lot of what we do zero copy stuff in PyZeroMQ. So when we were working on this, wheels didn't exist.
Wheels being the binary version that you get from PyPI now.
Yeah. So if you pip install something like PyZeroMQ, it doesn't compile it, right? You get a wheel and that just unzips it, and it's really nice. But at the time, there were only eggs. And there was a period of time when pip was taking over from easy install, which was eventually wonderful. But one of the drawbacks was during this time when pip was taking over, there was still no wheels. And so people had started shifting to pip because easy install did a lot of things that people don't like. But you had to use easy install if you wanted to get a binary, which means effectively, if you're on Windows, you had to use easy install. And so we had a really complicated, there actually used to be a big delay, might even still be there, in PyZeroMQ. No, this is definitely not so. There was a big delay in PyZeroMQ that if you ran setup.py, it would sleep for 10 seconds and show you a big message that says you might want to easy install. But now we're in a very different world, right? So even after wheels, it was a couple years before we had many Linux wheels, right? There was a while before you were even allowed to make wheels for Linux. And now we're at a place where we've got wheels for ARM Macs and ARM Linux and a bunch of different Linux versions and Windows and everything. And it's a really different world, and a lot of things would be different if we were starting this project now.
Right. It would be easier if you started now, probably, right?
Yeah, it would be a lot easier. We were getting in on some early stuff. But one of the wonderful things about Python is that if you're writing Python, you're really writing C, right? If you're writing Python code, it's generating a C program that calls the Python C API.
Right. And you write Python with a little typing stuff. It turns that into C and then compiles that to machine instructions, right? Like you're basically projecting C somehow. Yeah. Yeah,
and you're writing you're basically writing C that looks like Python. But the nice thing about C is that with directives and things, you can have one file that actually contains 10 different files because you could just turn off lines when it's compiling. And that means that it's much easier to write Python code that supported Python. At the time, we were supporting Python 2.5 through 3.1. And with a single code base, we had no 2 to 3, none of that. Single code base in 2010 supporting Python 2.5 and Python 3.1 and everything in between.
Wow, that's quite the accomplishment.
And the tricks were all dealing with PyZeroMQ. We were early adopters of a lot of the Python 3 concepts of we talk bytes, we don't talk stir. Right. Disambiguate. We use bytes and Unicode everywhere.
There's not necessarily that many differences between Python 2 and 3, but you could make them different, right? But in a lot of the more modern Python 2, you could still be much closer to what eventually became Python 3. Yeah.
Yeah, and so I would say it was either 3.3 or 3.4. It became the norm to have single code base, single syntax, support 2.7. So drop support for 2.6, support 2.7, and I think 3.3 or above, or 3.4 and above, whenever they let you back in, because then it became easier.
Yeah. Well, what's the story with Python 2 now? Does it still support it?
Just as of December, right? So Python 2 end of life was last December.
Right.
Python, so PyZeroMQ dropped support. The latest release requires Python 3.6 actually.
Nice. And I feel like a lot of people are going to 3.6. Why did you guys choose 3.6? Is it F strings or was it something else?
It was actually the typing.
All right.
So one of the main complaints about PyZeroMQ is it's so auto-generated and dynamically defined, right? Because we didn't just target multiple versions of Python. There's also multiple versions of libzmq. And that means that PyZeroMQ, what constants are defined is different depending on what version of libzmq is linked, which meant that a lot of the way it's written, a lot of static analysis fails. So when you're auto-completing based on static analysis, all the constants don't show up. And so that was an occasional, folks like, my autocomplete in PyCharm's not working. That's why I added the types, was to allow static.
Oh yeah, that's fantastic. Does it do anything with like what TypeShed does, where it's like defining the structure in these stub files?
Yeah, so so there's some type annotations in the pure Python code, but the relevant part was the stub files for the compiled.
Right. Yeah, and so if people haven't seen those stub files, those PYI files, it's a little like a C++ header thing where it has the definition, but then somewhere else is the implementation of it. It's a little funky, but yeah, it's also useful for adding that in, right? So you could say, here's the structure, and we'll make that at runtime dynamically, but this is what you should think of it as, right?
Yeah.
Yeah, very cool. Very cool. All right, Min. Well, I think we honestly just scratched the surface. We could go on and on and on, but at the same time, I want to be respectful of your time.
Sure.
So maybe we should wrap it up on the main topic there. So I'll ask you the two questions on the way out. So if you're going to write some code, if you're going to work on PyZeroMQ or something like that, what editor would you use?
So my favorite editor of all time is TextMate.
Okay.
But for various reasons, I don't use that anymore. It hasn't kept up with activity and things, and I didn't feel sustainable anyway. So I haven't used it in a long time. I've tried pretty much everything, and I'm in constant search of the next TextMate. So right now I'm actually using Nova, the new.
I was going to say maybe Nova is your next TextMate. How about that? Like I know if I say Visual Studio Code or PyCharm, people are like, oh yeah, I'm pretty sure I know what that means. Nova is pretty new. Tell folks about it.
So Nova is a new text editor from Panic, one of the great Mac developers.
Oh yeah, I use some of their apps, like a Transmit, for working with S3 files. They're really nice stuff. Yeah.
Yeah, so they do a great job designing things, and thanks to the recent work of the language server protocol and stuff, new editors are able to. There's a lot more shared infrastructure in editor features, so it's starting from further from zero than it might otherwise be. But I'm not sure I could recommend it widely to Python developers. It's a bit of an early adopter situation.
It is supposed to have Python support, but it's not specifically for Python, right?
Right. Yeah. No, it's a general purpose editor, and the target community is more in Mac developers, Ruby and web stuff.
Yeah, I feel like it's pretty JavaScript friendly.
Yeah,
and maybe Mac developers.
Yeah, and extensions are written in JavaScript. I've written a couple extensions for to use the darker code formatter.
Very cool. All right, well, that's quite neat. And I'm glad to hear that's working out for you. I've wanted to try it, but I just haven't. And then notable PyPI packages. I know you picked two that have some relation back to this challenge of building binary stuff and distributing it.
Yeah, so up until December, there was exactly one computer in the world that could build PyZeroMQ releases. It was my laptop. And I finally solved that problem thanks to two wonderful packages. One is CI build wheel, which is a more generally useful if you have compiled Python packages. CI build wheel is a wonderful thing for building and distributing all your wheels on all kinds of platforms. So now PyZeroMQ wheels are all built on GitHub Actions, and I don't need to do anything, tag a release, and it happens magically. Nice. The other one that I wanted to highlight that probably fewer people know about that's related to CI build wheel, because when you build a Python package that has an external dependency, there's an extra step to say, I built PyZeroMQ, I linked it against libzmq over here, but if somebody else installs that wheel as it is, it's not going to work because it's going to say, like, I don't have libzmq. So there, for a long time, there's a Mac thing called delocate and a Linux one called audit wheel that say, look at the binaries in there and find them on your system, bring them in, and update the linking to make sure they load. So the wonderful thing that I just found is someone created something called delve wheel, which is audit wheel or delocate, but for Windows. And I don't understand anything about Windows.
You go grab the DLLs and all that kind of stuff that have to be there, and put it in the right location. Perfect.
Yeah, and so for a long time, for I guess 10 years plus, PyZeroMQ built libZeroMQ on Windows as an extension. So it actually took the ZeroMQ sources and then just said, hey, I have this is a Python extension. You don't need to worry about the fact that it's actually a C++ library. Just pass it to disutils and compile it as an extension. And there were a lot of issues with that. You never got good optimized results. But it worked most of the time, and that was the point. And it was a wonderful contribution from Brandon Rhodes that was a huge step in making PyZeroMQ installable a lot more of the time, was this bundling libZeroMQ as an extension. But finally got to the point where I almost never do that anymore.
Nice, that's beautiful.
Thanks to delve wheel. So delve wheel is my big one.
Yeah, the CI build wheel one. It makes me happy to see the Mac OS Apple Silicon got a little checkbox there. That's what I'm doing or recording from on my machine over here. Got the Mac Mini one, and man, that is a sweet device. But you're a little bit back in like, oh, we don't have wheels for your system. Sorry.
Yeah, I have. So I have two Mac Silicon wheels. One that I just finished last week, but with CI build wheel. That's a universal wheel, and then I have another like Mac ARM wheel targeting Mac OS 11 Plus, basically just for homebrew Python on homebrew Python 3.9 on ARM Macs.
That's pretty specific, but yes, that's a thing I have actually.
Yeah, it's not an insignificant target, and that one I build on my wife's new laptop.
Nice, very cool, very cool.
So that's the only one that's not built on CI yet.
Right, awesome. Well, thank you so much for sharing all the stuff, and of course all your work. I feel like I have a lot to go learn, but it's exciting stuff to be able to think about new networking ways of doing stuff with networking and Python. So thanks so much for that. And final call to action. People want to get started with this stuff. What would you tell them to do?
So I'd say read the guide. So if you're interested in ZeroMQ, thinking about building distributed applications and things, read the ZeroMQ guide, the whole thing. And I think it'll give you some new ideas. Even if you don't use ZeroMQ, it'll give you some good new ideas for how. Yeah,
you'll have some ideas about like these design patterns that maybe are not so common, but like pub sub or whatever. Yeah, awesome. Well, thanks again for being on the show. It was great to chat with you.
Yeah, thanks so much.
You bet. Bye.